Now I need to mention engineering, structural engineering. This project has been carried out without any input from a structural engineer, and everyone seems very confident that the weight that these pillars are taking and these beams are taking is not an issue. But I certainly started to get concerned a day or so ago after I'd seen the amount of material that was going into this build, and not just the material but the weight of it. And I know how heavy these things are because, well, I don't know exactly how many kilos they are, but I know they're bloody heavy because every pack that I try to move, every board that I try to move is an absolute dead weight. So I started to get a little bit concerned, and I was asking Suntra, do you know how strong this steel is? Do you know what loads it can take? Do you know how heavy the building is? And of course the answer to all those questions is no. So I thought I'd better do some calculations and try and work some things out just for my own peace of mind, because the last thing I want to happen is that thing collapse. It'll take out the garage likely as not, take out a wall, probably do damage to the driveway, and it will probably kill someone that's anywhere nearby, and it will destroy any cars that are underneath, even in the garage. So I was starting to get a bit uneasy about being in this area until I knew how safe this thing was. So I did some research online, and the 6 columns are not an issue. They're easily able to support the weight of the building. I got Suntra to list me all the materials that we've bought and the quantities, and I wrote it down, and then I went online and found out how heavy they were. A lot of the material is actually defined in weight. There's one or two things that I had to make a guess at, so hopefully I've gone on the heavy side. So like the roof panels, all I know is they're relatively light, one person can carry them, so I sort of thought, okay, well, let's sort of call them 20 kilos each. They're a thin bit of metal and some foam, so they're probably nowhere near that. But then you've got some of some of the other bits of metal that are part of the roof. They were very light as well. I had to make an assumption on the steel. Just let this guy finish cutting. Yes, I had to make an assumption on the steel in terms of what quality and grade it was, and therefore how heavy it is, and also the strength of it. But it's the figures online were for commonly available steel, so we certainly haven't got anything special here. Obviously I know the thickness of the steel, and I know the lengths of it, and I know the dimensions, so that was what was used in the stress calculations. Anyway, I came to a rapid conclusion that this building is about 3 tons in weight with all the materials, excluding the posts. So the posts are holding up 3 tons in weight, so that's half a ton each. That's 500 kilograms for each post, which is well within its capabilities. I believe they're capable of holding 15,000 kilos each, something like that, I think. Certainly a lot more than 500 anyway. So the posts aren't an issue, but the cross members are, because attached to the posts are 3 main beams. So there's only 3 of them, and then going this way there's actually one beam that's actually supported. That beam there, that goes right the way through the front, that's supported by the post, so you can call that a load bearing beam. And that's it really, because the beam that goes right across the back isn't actually, which is that one there, that isn't actually directly sitting on the post. It's sitting on the cross member that's sitting on the post, so that's part of the load. It's not load bearing, as it were. So I worked out what was going on with these three beams principally to start with, and they came out below 1 as a safety factor, so I wasn't very happy with that. However, Suntory wanted to put these knee braces in, and they've put 3 knee braces in, sorry, they've put 6 knee braces in now, and I got them to do the maximum length that we could without having a problem with knocking our head on them or running out of steel, because we've used every last scrap of steel pretty much in these knee braces. So when you do the calculations on the spans now, which is basically the span is between the knee braces, that's reduced the span considerably, and the safety factors have all gone up and everything's hunky-dory now, in my estimation. Plus you've got this beam running across the front, which is directly supported on the posts, so that will take some of the load as well. That adds an extra bit of weight carrying capability to the structure. And I've worked out from the tables or the online calculators what weight that beam can carry safely. And then you've got things like the stairs, which are obviously going to take a little bit of stress and weight of the building because of the way they're constructed. So that joint there means that the building is sitting on that beam going down here, and it's welded at the bottom and bolted as well, so it's not going anywhere in a hurry. So that's going to help a little bit. I know it's not going to be a huge amount, but it certainly will help with weight bearing. And the other thing we've got to bear in mind is that this beam here at the back is on the outside of all the other beams, all the other weight transfers. It's actually transferring weight, its share of the weight, onto this section of beam, rather than the beam that's going between the posts. So that's going to be taking some weight away from the cross member there. And these are all tied in now to the garage structure by welding and bolting. So everything's designed to create more stability, but it's also spreading the load a little bit into other structures. So for those of you that are thinking of doing anything like this, building something on stilts, and it's a far more major construction than this, for goodness sake, get a structural engineer involved for peace of mind, because I have to say for 24 hours I was shitting myself, because I thought, well, you know, based on what I know so far, there's 3 tons of building that could come down in a strong wind quite easily, because a little bit of movement would stress the metalwork out a little bit more, and I wasn't certain that anything was going to work. But I'm comfortable now. I'm quite happy with it all, and I reckon the structure we've got, the supporting structure we've got, take about 7,000 kilos, and we're looking at a basic structure of around 3, and I rounded it up to actually make it 4. I think that's what I did anyway. Let's go and have a look at the figures. Okay, I've got pages of these notes here as I gradually got more into this. On that page, the list of all the materials, and then I worked out the weights, and then this was my first initial calculations based on just 3 beams, and then also some calculations for the posts. Oh yeah, the posts can hold 15,000 pounds each, not 15,000 kilograms. 15,000 pounds each. It's funny because the calculator online is a mixture of, you have to put some of the things in metric and some in inches and some in pounds, but basically I've worked out the building is 7,000 pounds in weight, rounded up. Because of the way it's constructed, I've decided that the weight distribution on the beams is even, especially now we've got those knee braces, because there's very little beam there, so you're not going to have a pinpoint load right in the middle. It's spread right across the beam quite evenly. In fact, you could argue that there's more weight load on the outsides of the structure than the middle. So more weight is loaded directly over the columns. Anyway, I came out with a safety factor of 1.658, which equates to a maximum load of 3,600 pounds per beam. Then you've got the other beams, they add another 2,400 pounds. So I reckon we can have a total load of 13,200 pounds on the supporting structure, which is 6,000 kilograms, which is double what I reckon the building is weighing. So even if I'm out slightly on my estimates for weights and I'm under, and even if we put a little bit of furniture in there, we're not going to have loads, we're going to be well within tolerances. The other thing is we've got the stairs, which I haven't counted, but they add a little bit of structural integrity to it all. So yeah, that's my little missive on structural things. Sorry it's gone on a bit, hasn't it? But I think in a way it's quite important to mention it, and there'll be some people out there who are experts at electrics who will be criticising my electrics, and some that will be criticising the quality of the build, and some that will be concerned about the structural side of it. So I'm trying to sort of give you an overview of how it's done here, and how I am trying to retain the safety features of these builds, like in the house that we built here. I insisted on RCBO electrical system rather than the standard MCB breakers that they all use. And I've put an extra RCBO in the garage here to give extra protection for the garage and the room. And I've used an RCBO system over in the farm over there when I've upgraded bits. So I'm trying to cover all bases here, and I know none of this is perfect. And none of this is how the West do it. We've had no building inspectors here. There's no rules or regulations to follow. There's no building standards, as it were. It's all done. It's all been done on the fly, and on the basis that the guys who've built it have had lots of experience of using steel, and they sort of know when they're doing it wrong in terms of weight. And they're the ones that decided what size steels to order because of their experience. So I'm comfortable with it. I'm comfortable with it now.